Have you ever encountered a puzzling issue in your JavaScript code that just doesn't seem to add up? If so, you're not alone. Today, we're diving into a common problem known as a race condition, specifically with the compound assignment operator in JavaScript. I totally get how frustrating it can be when your code doesn't behave as expected. You write everything perfectly, but the results are still off. This is a common issue many developers face, especially when dealing with asynchronous operations. Let's take a look at a specific case. One user recently asked, "Why is my accumulator not summing correctly when using the plus equals operator in JavaScript?" They shared a code snippet where they expected the accumulator to equal 10.3 after running two functions in parallel, but instead, it only returned 5.3. Sound familiar? Let's explore this together. So what's happening here? The issue lies in the fact that the plus equals operator is not atomic in JavaScript's V8 engine. This means that when multiple asynchronous functions try to update the same variable at the same time, it can lead to unexpected results. Let's break it down step by step. And stick around. At the end of this video, I'll share a crucial tip on how to avoid race conditions in your JavaScript code, which will save you a lot of headaches in the future. To address the race condition in the user's code, we will first modify the way the accumulator is updated. Instead of using the compound assignment operator, we will use a more controlled approach. Next, the user should implement a locking mechanism to ensure that only one function can update the accumulator at a time. This can be achieved using a simple flag. Now, the user needs to ensure that the accumulator is updated safely within the asynchronous function. This means checking the lock before updating. Finally, the user should test the modified code to verify that the accumulator now reflects the expected total after running the functions in parallel. Fun fact, did you know that race conditions are named after the idea of two or more processes racing to access shared data? Just like a race, the outcome can be unpredictable. Now let's look at the answers provided by other users. One user suggests a simple fix to avoid the race condition. Instead of using the compound assignment directly, they recommend separating the await call from the addition. By first storing the result of the await in a variable, then adding it to the accumulator, the race condition is resolved. They speculate that the V8 engine may not optimize the compound assignment as expected, leading to unexpected results. This approach clarifies the operation and ensures the accumulator is updated correctly. Here's the tip I promised. Always be cautious when using shared variables in asynchronous code. Consider using atomic operations or libraries designed to handle concurrency safely. And there you have it. Understanding race conditions can significantly improve your JavaScript coding skills. If you found this video helpful, please hit the subscribe button for more tips, and don't forget to check out our next video on mastering asynchronous JavaScript.